Hello, welcome to the second episode under the Silly Solar Power. In today's episode, we're going to talk about sizing the batteries. So in the last episode, we sized our inverter. We chose an inverter of 5 kVA for 8 volts. Keep that in mind. Today, we're continuing to size the batteries of our system. In our example, we had 5 appliances that are going to be used in our house. A depressing element, 2000 watts, lights, TV, radio, and a refrigerator. These are the wattages. So when you're sizing your battery, you have to know how long each one of these is going to work. Because that one to give you the total energy that is required. In this example, the house had one pressing element, it had 10 lights, had one TV, one radio, and one refrigerator. Should also be mindful of the times of the day when each of these are going to land on the batteries, because there will be some time they may be landing directly from the panels without using the battery. Or some appliances such as the lights are used during night, meaning that they'll be full on battery. So pressing alone, for how long can it land? Maybe this one set can go for maybe 1 hour of ironing. The lights can be switched off from 6 to 6 in the morning. So they go for 12 hours. While this one, the TV may be for 2 hours, 2 hours in a day. The radio may be another 2 hours. A refrigerator, normally blood may be from around 4 when there is no power, up to around maybe when there is no sun rather, up to the maybe around 8 a.m. in the morning when the sunlight intensity is low. So we can say maybe this one can take us 14 hours. Okay, so that's our example, how these are going to land. So let's find the total watt hours that we're going to need. Remember, watt hour is another unit for energy. We can go into questions how we come up with watt hour, but maybe for practical sake, let's leave as it is. We leave the current issues because they're all embedded in here. The footage, they're all in here. The joules, blah, blah, blah. But for now, for practical sake, we take the watt hours. Okay? So for fridge, you need 2000. For pressing alarm, we need 2000 watt hours. For the lights, we need 1200 watt hours. For the TV, we need 600 watt hours. Radio, 100 watt hours. While for the refrigerator, we need 4200 watt hours. So these are the energy requirements for each of the appliances that are going to land from our batteries. Let us find the total. In this household, they need about 8,100 watt hours in a day to operate all the appliances which they're going to use their system. So this is the energy requirement for this household. That's what we're going to draw on to size our battery. Let's continue. One thing that we have to remember is batteries are sized in amp hours. 200 amp hours, 100 amp hours, 50 amp hours, 300 amp hours, 150 amp. That's 100 AH amp hours, 200 AH. So we have to find how many AH we need for this system. Remember we said we chose 48 volts system or battery. So if you have 8,100 watt hours for 48 volt system, what size should the battery be? Remember here, to have the hour, is equal to volt times ampere from the previous example. And we said, for us to find this watt, we have to use a power factor of 0.8. Okay? So in this case, we are going to divide by the 8,100 watt hours. We are going to divide by 48 volts, considering the power factor. That one will give us the amp hours. Let's do it. So in this case, it's like we have 8,100 volts amp hour. Okay? To find amp hours, we're going to divide by 48 volts multiplied by the power factor, 0.8. There's another thing that we have to multiply by here, the depth of discharge. This depends on the batteries that are going to use. If you're going to use lithium-ion batteries, they have a depth of discharge of about 90%. You can use it from 100 to 90. It reserves the 10. If you're going to use the lead-acid batteries, they have, most of them, they have depth of discharge of about 50%. Use from 100 to 50, then it cuts for safety. So in this case, the first example, we assume we are using lithium-ion battery with 90% depth of discharge. Remember, 90% is like 0.9, so multiply by 0.9. Let's find the amp hours. So we are going to find that it is equal to 234.7 Ah. This is the battery size which you need for lithium-ion batteries. Okay? These are required capacity. At 48 volts. But remember, this capacity at 48 volts, we have to look on the market. What sizes do we find on the market? Normally on the market, you can find 100H, 200H, sometimes 300H, sometimes 150H, 48 volts. So assuming we found that there is 150H, 48 volts. In this case, we're going to choose two 150H, two 150H batteries at 48 volts, and we connect them in parallel. So that's it. We need two 150H batteries of 48 volts to satisfy our requirements, connected in parallel to maintain the 48 volts. This is the end of the second episode, sizing the battery. See you next time when we are doing the last episode, sizing the solar panels.